Okay, we are solving May-June 2022 paper 22 9702. This is physics AS paper, theory paper. Now, in the following list, underline all the units that are SI base unit. Ampere, just 1 second. Ampere should be underlined, and kilogram. Celsius is not um, SI base unit. Similarly, Newton is SI unit, but not SI base unit. Figure 1.1 shows a horizontal beam clamped at one end with a block attached at the other end. The block is made to oscillate vertically. The Young's modulus of the material is this, where m is the mass of the block, p is the period of oscillation, and k is a constant. Quantities k, m, t have uncertainties like calculate the percentage uncertainty of E. Percentage uncertainty of E will be that will be adding uncertainty of K, M, and T. K is 2.1 plus M is 0.6 plus T is 1.5 plus 1.5. You would say, why did I do 1.5 plus 1.5? Answer is that because there is a square on T. So this means I have to add T's uncertainty twice. But if you don't want to add it twice, you have to multiply it with 2. Or what you could do is multiply by. So it will be 2.1 plus 0.6 plus 3.0, 5.7%. So 5.7% is the percentage uncertainty of E. Remember, this percentage uncertainty belongs to this value. This is percentage uncertainty to this. Now we have to write down the final answer. 8.245 into 10 to the power 9 Pascal plus minus 5.7%. First of all, find 8 5.7% of 8.245 into 10 to the power 9. So what is this?
Sir, 0.47 into 10 to the power 9.
Sorry?
0.47
0.47.
into 10 to the power 9.
Okay. So this will be the percentage, this will be the absolute uncertainty. So this means we have 8.245 into 10 to the power 9 plus minus 0.47 into 10 to the power 9. If we take 10 to the power 9 as common, it should become 8.245 plus minus 0.47 into 10 to the power 9 Pascal. Now, here's the thing. We have to round off this figure to one significant figure. So it will become 0.5. And this will control the number of significant figures in the final answer. So it will be 8.2 plus minus 0.5 whole into 10 to the power 9 Pascal. This is how we can excuse me. This is how we are supposed to solve this question. It will be 8.2 plus minus 0.5. And if you want to take two decimal place for the two same figures in the error, it will become 8.24 plus minus 0.47. But this is better. Always round off the uncertainty, absolute uncertainty to one single figure, and control the number of decimal places in the normal quantity based on your uncertainty. So this is question number one. Now go to question number two. Now, a sphere is attached by a metal wire to a horizontal surface, balloon, so and so. The sphere is fully submerged in the liquid. The wire is an angle of 68 degrees to the horizontal. The water is this kg per second. The upthrust on it is 280 Newton. The upthrust, the force that is trying to pull the ball up is 280 Newton. Now assume that the force on the sphere due to water flows in a horizontal direction. By considering component of the force in the vertical direction, determine the tension in the wire. Now, weight is acting downward. Now, this tension is acting at an angle. So tension will be having a component like this. That will be T cos theta. And there will be a downward component like this, which will be T sine theta. T cos theta and T sine theta. By considering the component of the force in the vertical direction, determine the derivative. Now, P sine 68 plus mg is 32 equals to, this is total downward force, weight, and the tension's vertical component. They're both acting in the downward direction, equals to upthrust, which is 280. So T equals to 280 minus 32 divided by sine 68. Two 48 divided by sine 68.
270.
270?
Yes.
Two 270 will be the answer. Confusion?
No, sir.
For the sphere, calculate the volume. Now, if you know upthrust and you know the formula for upthrust, which is volume into density of the fluid into just 1 second. Okay. Now, we know the formula upthrust equals to density volume G. So volume will be equals to upthrust divided by density, which is 1000, and gravitational acceleration is 9.8. So 280 divided by 1000 divided by 9.8. So
0.029.
0.029
029.
meter cube. I'm just trusting your calculations and your values. Okay. The density. Density is mass over volume. So mass will be equal to, what is mass? Mass will be 32 divided by 9.8, because 32 is the weight. And when we divide weight with 9.8, we get mass, and then divide it with 0.029. So what do we have over here?
Sir, 110.
Sorry?
110.
100?
10.
Okay. Kilograms per meter cube. Okay. Now, the center of the sphere is initially at a height of 6.2 above the horizontal surface. The speed of the water then increases, causing the sphere to move at a different position. This movement of the sphere causes the gravitational potential energy to decrease. Decrease means the object goes down. Object moves down. Calculate the final height of the center of sphere above the horizontal surface. Now, first of all, you have to find the change of height. So as the speed of the increases, the causing the sphere to different position. This movement causes the gravitational potential energy to decrease by this. Mm. Was the height given? A sphere is so and so. Okay. Object moves down. Oh, this is what I was looking for. Initial height is given 6.2. Now, change of potential energy equals to mg delta H. Delta H equals to delta energy divided by mg. So it is 77 joules divided by 9.81 into g is mass is, what is mass? Mm, Mass will be weight over gravitational field strength. So, oh, I can just directly put mg over here. Mg is 32. So,
Sir, 2.4.
77 divided by 3, 2.4. So this will be 2.4 meter. New height, change of height equals to energy divided by mg. Now, Gravitational energy lost by 77 divided by mass is 32 divided by 9.81 and G is 9.81. We have just calculated that. Oh, sorry. We we already have fall in height. Initial height is 6.2 meter. Final height be it will be 62 minus 6.2 minus 2.4. But be very careful. In case if energy is lost, then you have to minus. Otherwise, you have to add. Final height will be 6.2 minus 2.4, 3.8. Final height will be 3.2 meters. Now, in the next question, the extent of the wire increases when the sphere changes position as described in this the wire obeys Hooke's law. State an example, a simple equation that gives the relationship between the tension T in the wire and the extension X. Identify any other symbols that you have used. So what are the formulas that connect over here? The extension of the wire increases when the sphere changes position. Now, state a simple equation relationship between T in the wire and the extension X. T equals to Kx, where K is spring constant. Now, before the sphere changes position, the initial elastic potential energy of the wire was 0.64 joule. The change in potential energy of the sphere caused the extension of the wire to double. Calculate the final elastic potential energy of the wire after the spring has changed position. Now, all you have to do is just find the new potential energy after the change. Now, in order to do that, we start with basic information. Maximum energy stored equals to 1 over 2 K x naught square equals to 0.65. Can you use this one to find okay, we cannot find K. Find last rotation energy of the wire after the sphere has changed position. Just 1 second. Okay, listen. Elastic potential energy is directly proportional to extension square. Elastic potential energy equals to 1 over 2 K x square. Now, the change of the sphere caused the extension to double. Now, elastic potential energy and extension. If this is 1, this is 0.65. If extension doubles, how much will this be? Remember, there are squares over here. So x equals to 0.65 into 2 square 4. So it will be 2.30 joule. So 3.20 joule of
It's
energy.
2.6.
Sorry? Oh, 2.60. So that's it. Because remember, energy and extension are directly proportional, but there has to be a square on displacement. Okay.
Okay.
Now, next question देखते हैं जी, जल्दी से. A man standing on this and this 5.6. The ball leaves the hand at height of 3.1 meter above the ground. Show that it reaches a maximum height of 4.7. 2gh equals to v square minus u square. So 2 into minus 9.8 into h equals to 0 square minus 5.6 square. So h equals to 5.6 square. 5.6 square divided by 2 divided by 9.8. 1.6. So height is 1.6 meter. An object goes 1.6 meter higher above 3.1. Final height equals to 3.2. Oh, sorry, 3.1 plus 1.6. So 4.7 meter. And shown. The man does not catch the ball as it falls. Calculate the time taken for the ball to fall from its maximum height to the ground. Now, initial speed will be 0. Height to fall down will be 4.7 meter. Acceleration will be 9.81. And maximum height to the ground. U equals to 0, H equals to 4.7, this, and he's asking for time. Now, which formula can connect these 4 variables together?
Mass is equal to ut plus 1 by h square.
Good. So that will make it 4.7 equals to 1 over 2 into 9.81 square into 2 half a t square. T is squared. So t equals to 4.7 multiplied by 2 divided by 9.81 whole square root. So 4.7, the double of 4.7 is 9.4. 9.4 multiplied by 2 divided by ये just 1 second. Time taken for the ball to follow this. State what is represented by the gradient of the graph. Which question am I doing? We just forget it. Now state what is represented by the gradient of the graph in C. This is a graph of velocity V, and on x-axis okay. State the represent by the gradient of the graph. Gradient will be V stands for velocity. So velocity divided by time is acceleration. So so it is represented by the gradient of the graph. Acceleration at the point. The man now throws his second ball with the same velocity and from the same height as the first ball. The ball second greater than that of the first ball, assuming that a resistance is negligible. For the first and the second ball, the magnitude of their acceleration will be same. Now the speed with which they hit the ground. Now the speed with which they hit the ground. What will be the speed they are hitting the ground? I don't think कि मैं ज्यादा देर पढ़ा सकूंगा, मुझे बार बार नींद आ रही है। आज थोड़ा सा रेस्टलेस हुआ हूँ। कल यार कल भी नहीं कर सकते ना, इसको हमको खत्म भी करना है। क्या करें? तो एक ट्राई करते हैं। देखो चाहे मैथ ज्यादा हो कम हो, if you drop something with the same speed, it should take same time because acceleration is independent of masses. The magnitude of acceleration will be same. Acceleration equals to weight to mass ratio. Okay, so they both hit the ground at same time, so they take same time to fly because time is independent of mass. If we calculate time, any formula of time in equation of motion, there's no influence of mass, so they both will hit at the same time. अच्छा आज बस करते हैं, कल इसको इंशाल्लाह कंप्लीट कर लेंगे।
Okay. Allah Hafiz.